Hello and welcome to a video tutorial learning about graphs of linear inequalities in the form x is greater than some constant number. Okay, so here we got an inequality. X is less than or equal to -4, and we want to represent all the possible points, ordered pairs, x and y values, that make that inequality true. And this one is a little bit confusing for students because there is only one variable. X is less than or equal to -4. We've actually graphed those on a number line, but here we're dealing with two variable linear inequalities. So if I have this whole coordinate plane here, x and a y-axis, how do I graph all of those points? Well, it's very similar, but let's start off just by looking at some points, some ordered pairs that do satisfy that inequality. So ordered pairs that are true. Again, we're looking for points, x and y, that have it so that x is less than or equal to -4. All right, well, let's list them out. We have -5, 8. -5 is an x value, less than or equal to -4. We could have -10 and 1. We could have -8 and 3. And we could have -4 and -4. -4 is an x value that is less than or equal to -4. So it also would be considered a point that would satisfy that inequality. All right, so let's graph all these. -5, 8 would be up here. -10, 1. -8, 3. And -4, -4. All right, there's 4 points. Those all satisfy that inequality. X is less than or equal to -4. All right, let's look at some points now that are not true. Ordered pairs that are not true. Underline not. So these ones are x and y values. However, they don't satisfy an x value less than or equal to -4. So some points there would be 8, 0. 8 is not less than -4. 0, 7. -3, 2. Or 1, 1. So all those points have an x value that's not less than -4. All right, so let's graph all these. 8, 0 would be right here. 0, 7 would be here. -3, 2 right there. And 1, 1 right there. So you can kind of see a pattern. Looks like the blue one's on the left side, red one's on the right side. But there we go. We've got some points. We're kind of thinking about what points work and what points don't work. Let's go into thinking about how to graph general equations then. What if I gave you the equation x equals -4? How would I graph that line? Well, that line is the graph of all the points that have an x value of -4. So let's find -4 for x. It's right there. And all the x values that are -4 are going to be right along this line right here. In fact, I'm going to go ahead and make a solid green line representing the equation x equals -4. All right, that's the line represented by all the points that have an x value of -4. Well, just like we did in the last video, let's look at this now. All the x values that are less than -4 have to be to the left of that graph, right? Because that's where x values get to the left. I'm going to go ahead and shade all that area. You can see a lot of our points actually are in that shaded area for solutions. Now all the x values greater than -4, well, they're going to be on the other side of the green line. They're this area over here. This region that I'm shading here represents all the points that have an x value greater than -4. And the green line are all the points that have an x value equal to negative 4. So kind of 3 different regions depending on are we greater than or less than or equal to. Now, what we see then is when we're dealing with inequalities in the form x is less than or x is greater than some value, some constant, we're dealing with vertical inequalities. There's a vertical boundary line that we need to find. So we need to find the vertical boundary line. We need to determine by the inequality, is it a dashed line or is it solid? Again, it's solid in this case because we have less than or equal to, which is why this particular point we marked as a solution because it's equal to the line and less than the line. So anything less than or equal to fits this inequality. So this inequality is represented by the solid green line and the shaded blue region. So we had a solid line in our inequality. We made the vertical boundary line by x equals 4, and we shade based off greater than or less than. And we shaded to the left because it was all the x values less than negative 4. Hopefully this is a helpful thing to help get you understanding about linear inequalities, in particular in the form x is less than or greater than a constant value, which gets kind of tricky because there is no y value. There's no slope, intercept, form, all that kind of stuff to work with. But we do a lot of these kind of scenarios when we're trying to model certain situations. We need inequalities of this form and understand how to graph inequalities that are vertical inequalities as well.